Okay, so if we have our north and south pole and we have a bar across the two electrodes and we pass a current through, what we notice, and there's quite a bit of writing here, is that when a current is passing through the bar, and the bar is inside a magnetic field, the bar experiences a force. Okay, what we mean by experiences a force is it moves. We can control the direction that bar rolls. How would we do that? Correct, okay. We can change the way the voltage, the electrons are passing through the wires, and that will change the way that the force affects the bar, causing it to roll in a different direction. So to change the direction, the bar moves. Either reverse the current, there's something else we could do with the magnets. Swap them around, correct, well done. So to change direction, the bar moves, either reverse the current or the direction, run out of space, of the magnetic field. Now this is called the motor effect. Does anybody know what motor this happens in? And you'll all have probably been in a situation where this has happened. Okay, when you turn the key in your car, that turns this engine called the starter motor. You may have heard that phrase. The starter motor is a small motor which is used to turn on the big engine. Okay, so the starter motor provides an electric current which creates an electromagnetic field which gets the little starter motor spinning. That can then engage the engine, which gets the pistons moving, which starts the whole process of combustion, which gives you the power to drive your car. You can work out how the motor is going to spin and which way it's going to spin with another rule, which is known as the right-hand rule. So we have a left-hand rule and we have a right-hand rule. Fleming's right-hand rule can be used to describe the direction of the force. If you point your hand like a gun, the motor effect, okay, the first finger, the direction of the magnetic field, which is this one. We'll maybe color code these. The second finger is the direction of the current. And the third finger is the motion, the direction of the motion. Let's go for green. Okay, so over the page, let's have a look at this example. An electric current produces a magnetic field. If a current carrying conductor is placed in the field, both the wire and the magnet will try to move. There is a force between them caused by the interaction. This is the motor effect. The biggest effect is produced when the conductor is right angles. So what does this mean? So the first thing you have to do is work out the direction of the magnetic field. And the magnetic field always goes from north to south. Okay? The next thing we need to work out is which direction are the electrons going from the battery, towards the switch or the other way. The electrons in the wires, Where are they going? They go towards the switch, okay? So the electrons are traveling round. Okay. So if you take your right hand and you point from north to south, and you align your middle finger with the direction the current is flowing, and I'll do this on the board in a second, your thumb is pointing down the way. So this motor, this wire, is going to spin down the way. And I'm going to have to pause the video.